Optimizing Queries Part 1 of 2. Here we start to shift our focus into the second half of this course, where in the first half, as you know, we studied the security aspects of MySQL Server. Now in the second half, we look at optimization, troubleshooting, and performance tuning. In this two-part mini-series, we look specifically at optimizing queries. As a relational database system, MySQL is going to be really a query engine. A query at root is a question. So how can we configure MySQL to handle and answer these questions as efficiently as possible? We'll start the nugget with a consideration of query analysis basics, getting our ground level understanding intact, making sure we understand the relevant nomenclature and so on. And then I'll introduce you or give you a further understanding of, if you've already got a little bit of experience, using the explain statement. This is going to allow us to drill in and actually see what the MySQL Query Optimizer component does when it fulfills a query and brings back those rows to the querying user. What are the basics of query analysis? Simply stated, our goal as MySQL database administrators in this context is we want to identify poorly performing or slow queries. Now, I stated earlier in the course what I consider to be one of Warner's maxims of IT, and that is no matter how much time we administrators spend in tweaking and tuning our database performance, and however quickly we feel the system's running, all of our users will never be satisfied. There'll always be some who complain that the system runs slowly. That's just a way it is. Now, of course, getting into real world stuff, the people that we're especially concerned with are the upper management, the people who are signing our checks. Now, what's cool about query analysis in relational database management system and from our perspective as DBAs is that we can start to use some of these analysis tools, one of which we're going to use in this nugget, the explain statement, where we can start backing up some of the touchy-feely, well, these queries feel slow. I mean, I hit a button in my line of business application and I see rows coming back and it seems like it's taking seconds or it seems like it takes an awful long time. Well, once we start using some tools, we can generate actual data and numbers and charts and graphs to show the people who sign our checks and make a case, for instance, to purchase additional hardware and additional infrastructure and develop solutions. And this is great, of course, because it preserves our job security, let's be real, right? But of course, it's going to, in the end, give us a better performing database back end and hopefully happier users. Now then, what are some sources of information? Number one, this is something that I really can't teach you and something you really can't buy even with nifty first-party and third-party tools. You simply have to know and possess an intuitive, in-depth knowledge of your application, your LOB or line of business applications that rely upon MySQL. You have to be really intimately familiar with MySQL. That's obviously why you're watching this training series, to develop those skills, but it doesn't end there. Remember, your queries originate in a front-end application. It's likely doubtful that your front-end users are using the actual inbox MySQL client. Sure, you use this as an administrator, and this is what you'll be tested on as your query tool on your exams. But dollars to donuts, you have a web or graphical or maybe a proprietary command line application that your users send those queries to the backend MySQLD with. And you need to understand how that app functions, how the app packages those queries, and see where that may be impacting query performance, in addition to looking what's happening on the backend in MySQL. Speaking of which, on the backend in SQL, we have some nifty tools in our toolbox. One that we'll look at in the demo is Show Process List. Now, those of you who are coming from a Microsoft SQL Server background, you're used to the Activity Monitor, the graphical utility that shows all of the processes or connections, aka users or applications, who are attached to the server, what queries they're currently executing against the server, which databases, which batches are running, what locks are being granted, if there are any deadlocks happening, who's blocking whom, do you have to come in and resolve any of those blocks, and so on. Well, show process list is an equivalent, albeit a much more basic stripped down equivalent in MySQL Server. Now, if you run show process list as a standard MySQL user, logic should tell you that all you'll be able to see are your own processes. If you run show process list as a privileged user, a super user, or the MySQL root, then you can see all of the processes that are active on that server. And you can run the kill command to dump one of those processes. The user doesn't get any warning or error or any message. Well, they'll see an error certainly, potentially, but that kill doesn't give them any informational message, so be careful using that. Sources of query information continued. Whereas the show process list command is nice because it gives you an idea of A, who's connected to your MySQL server right now, and B, an idea of the current queries being processed or handled by the MySQL parser and the MySQL query optimizer, again, right now. You're not gathering historical data over time. And that can present a weakness because you as an administrator have greater things to do with your day, I presume, than sit there and watch show process list output for 8 hours a day, you see? Therefore, we need to turn to our trusty server log files and take a look at those on a pretty regular basis. Now, as previously discussed, the regular general purpose error log is the only of these 4 logs that are enabled by default. All of these logs exist in your data directory, the default directory where all of your database table files are located. We're not talking about the error log now, though. We're talking about the 3 other logs that are specifically related to queries that do have to be enabled manually. You can either fire these up interactively by starting MySQLD with a particular -- operator, or more likely what you're going to do is attach a proper directive to your MySQL option file. Alrighty then. The first of these log files we'll consider is the general query log. You can use the general query log to get a historical heartbeat of the server's query performance or query operations. Now, this query log is going to get big pretty quick, obviously, depending upon how heavy-hitting your time of day and query load is. To start the query log, you would just open up your option file, navigate to the MySQLD portion, and depending upon which version of MySQL you're running, if you're on MySQL 5, you would just put one word, log. And you can actually throw in an equals and then specify a different path and a different file name if you want to. If you just put in log, then the file will show up in DataDir with the default name. If you're running 5.1x or later, the directive has changed a little bit. It's actually general _ log. Just that one term, and bounce the MySQLD, and you're off and running. Remember, because every single query is going to get echoed, it's almost like a keystroke logger. You'll want to turn this off when you're not doing your performance tuning or troubleshooting. I believe we've already spoken of the binary log a little bit earlier when I mentioned the importance of running backups. I said that the binary log is a special purpose log that stores only those SQL statements that change data in your tables. In other words, they store updates, inserts, and deletes. To enable the binary log, all you have to do is put in a directive log-bin in the MySQLD portion of your config file and restart MySQLD. Now, whereas the general query log can be a good source because it captures all queries, select statements in particular, binary log can also be helpful in looking for query information and trying to diagnose which queries might take longer than others. And you might be thinking to yourself, scratching your head, well, if binary log is not logging select statements, Tim, how in the world can the binary log help us? Well, you're seeing the answer right here, friends. I'm kind of letting the cat out of the bag. You would look for those inserts, updates, and deletes where you find where statements. You'll be looking for a lot of where filtering and think to yourself, okay, well, I'm seeing a lot of operations that are specific to certain columns and you might want to do a little bit more investigation on those tables and on those columns, perhaps in your general query log, perhaps in your slow query log, which we haven't talked about yet, and these might suggest indexes to you. And ultimately where we're going here, the ultimate way to obviate or fix slow query performance is to build out your indexes. That's the ultimate solution here, really. Finally, we have the slow query log. The utility of the slow query log is pretty obvious. This is a log you can enable specifically to capture long-running queries. Now again, the enabling of this, the syntax is going to depend upon whether you're on MySQL 5 or 5.1x. For MySQL 5, the earlier one, you would put in the directive log_slow_queries. For 5.1.x, it's actually slow_query_log. Now, my handwriting there is absolutely pathetic. I apologize to you about that. There's a great article here that sums up the MySQL server logs in the MySQL reference manual. Certainly check that out. It gives you all the skinny on all these. And actually, to tie this to an earlier lesson I gave you on upgrading MySQL, I made the statement that as you get further along in development branches of MySQL, you get different changes. You get deprecated statements, changed features, changed statements. Here's a good example of that, where the MySQL team is deprecating certain statements here and changing up the syntax. And if you're not aware of a change, you're going to get kind of left in the background. Now, to sum up about the slow query log, you might be asking, again, this is a logical question, what defines a slow query? And that's a great question, actually. There's another directive you would add immediately after either log slow queries or slow query log, and that is, you guessed it, long query time. And these are underscore characters, long underscore query underscore time. Now, you don't need to do the long query time directive if you think 10 seconds is an appropriate threshold for long queries. You can crank that down if you think 3 seconds is too long, and you can look up the specific article on long query time if you want the full gamut in terms of low values versus high values and its full syntax. I'm going into more detail than you need to know for the exam. For the exam, simply know what the slow query log is, know how to enable it, and know that that duration, that threshold value, is controlled by the long query time directive. It's now time to introduce this explain keyword, because here, now that we have some background on sources of information for identifying slow queries, let's transition into using the explain keyword to analyze those queries in greater depth. In MySQL, explain is a function that works in conjunction with the select statement to display how the MySQL query optimizer will process a query. Now, when you use explain, the select statement doesn't actually return the rows, but what it'll do instead is give you just metadata about that query in question. Let's take a look at the sample code. We'll dive right in, and I'll show you how it works. So in this case, we would say explain select star from country where, in this case, code equals FRA. This is just a very basic select from a single table, and we're looking for a code which, if memory serves, code is the primary key column from the country table. And I found when we used explain, it's best to use the \G escape character to view your output in a vertical row display. Now, what you get back are a number of columns here in the explain result. Some are more important than others. Now then, in the select type, there are a bunch of different options here. Mainly, you're going to see simple. Simple just refers to a simple select that doesn't use the union operator or doesn't involve any subqueries. There's a really great article in the MySQL reference manual called Optimizing Queries with Explain that gives you a detailed explanation of every single one of these fields. I'm just giving you the basic what you need to know for the exam. And we'll do a demo where I'll show you a live example of this as well. Of course, we have the table in question. Type is probably one of the 2 or 3 most important fields, because type is going to give you how are the values read from the table. And to give you just a very quick overview of the Query Optimizer, the worst way to pull back rows from your table data is to perform what's called a table scan, where MySQL has to go literally row by row by row through your table to pull back your data. Now, on a table that doesn't have an index, that's really the only way that MySQL can pull the data. Even if your table does have one or more indexes, when you're doing a select splat or select star and you're not using where, group by, and so on to further filter that data, sometimes a table scan is still the quickest way to go. But you, in general, don't want to use a scan. Now, if you do use a scan, the type is going to show up as all. So your take-home message, friends, you want to avoid seeing all as your type in your explain statement. Really, there's a hierarchy of like 10 or 11 possible values for type, where the best is either system, if the result is coming from a system table, which you're not going to see all that often. Really, for all intents and purposes, the best couple options you're going to see are either constant, C-O-N-S-T, or EQREF, equality reference. Now, the constant would be, for instance, if you did a select star from country where, well, kind of like what you're seeing here, where you're looking for a specific value in a primary key field. And that's exactly what we see in this example. The type in this example code is using the constant type because we're bringing back just a single row. The table has at most one matching row that's read from the start of the query. The EQ_ref type is used when you've got a query that involves a join. And that's actually the example we're going to do in the upcoming demo. Queries get more complex, as I'm sure you know, when you're pulling columns from one or more joined tables. The more tables you join together with related columns, the more rows potentially a table scan has to take into account. I mean, if you had 10 rows on table 1 and 10 rows on table 2, let me get rid of that third table for just a second. It's not just a case of looking at 10 rows here and 10 rows here. Because of the join column, we have to look at all combinations of rows between those tables. So we look at a product, 10 times 10. That's 100 possible rows. Well, that's just for tables that have 10 rows. What if your tables had 1,000 rows? 1,000 times 1,000, you see what I mean? So in terms of query performance that involve join tables with lots of rows, you certainly wind up with queries that can become abysmally slow if table scans and not index seeks, which is the other way to go besides a scan, are employed. We talk about indexing in great deal of depth in the CMA and DBA1 CBT nuggets. Alright, so far we're working our way through this list. I've talked about the type. All means we're doing just a raw table scan and indexes are not used. The best couple types we're looking for are either the constant or the EQREF in the case of a join. If the Query Optimizer is using an index, you're going to see some values for possible keys and key. Possible keys means that MySQL sees one or more indexes for the table. And let's say if this country table had 2 indexes, they would show up one after the other in a comma-separated list. Here, primary means that MySQL Query Optimizer sees that the country table has a primary key index attached to, and I happen to know this, the code column. And the key means that in this query, the Query Optimizer is in fact going to use that B-tree index on the code column to satisfy this query. The key length is 3 characters deep. Ref denotes either a join or, in this case, because this is a single table, it's referring to a constant value. We're looking for just a single discrete row in this table, a code of FRA, and the final value that's really important that we're looking at from an optimization standpoint is the row count. So to take that slow explanation and to summarize it and distill it right down to the quick, when you run an explain or when I run an explain, the really quick scan that I do is I look through here and I quickly see, is an index being used? Yes or no? what kind of type is being found here. Is it a constant? Is it an ecref? Is it all? If there is an index being used, is it having an effect on row count? The bottom line, as you're going to see, especially in a table join situation, is that you want to see your row count get smaller and smaller and smaller. Because as you saw here, in the case of joined tables, we always have to remember when tables are being scanned, it's always the product of rows. Like if we have to scan 1,000 rows here and 100 rows here, we're looking at the product for the ultimate possible row count for rows that have to be scanned. So if we can reduce the number of rows that are scanned or seeked, if that's a proper English term, sought, I guess is the English term, then that is obviously going to dramatically decrease the amount of time that the MySQL Query Optimizer takes in satisfying the query and then bringing the final row set back to the user. In our demonstration, we're going to work with, of course, identifying queries for analysis. We're going to use that show process list command, and then we're going to build out a few tables and use the explain statement and see if we can't make some sense and turn some theory that we've covered in the previous half hour or so into reality to solidify our exam objectives, to make sure they're solid not just for your test, but for your real life work as a MySQL DBA. Let's get this demo going. In this demonstration, we're going to work with the basics of query analysis on LinNugget 1, our Ubuntu Linux machine. Everything we do in this nugget is completely transposable to Windows, so again, it doesn't matter which OS platform we're on. To set the stage for this nugget, we're going to enable the general query log and the slow query log, and heck, we'll even enable the binary log just for grins. To do that in Linux from the command line, I'm going to sudo pico, and by the way, in this Nugget series, you see that I'm using the Pico text editor. Obviously, you can use whatever text editor you want to open up your my.cnf configuration file. This is just a standard plain text file. I like Pico because it's simple and easy to use. Alright, so let's come down into the MySQLD section, open up a couple blank lines. To do the general query log, as you know, we just do general _log. log-bin for the binary log, log-slow-queries for the slow query log. Alt-O to write the file, Alt-X to quit. Now we're going to sudo etc initd MySQL restart to restart the MySQL daemon. We'll now log into MySQL server. And we're going to use the world database. The example we're going to use in this demo comes from the MySQL 5 certification study literature. I'm adapting that example for our purposes here, and it's going to tie together very nicely the principles we've learned of query analysis over the previous several minutes. Now, in the meantime, we're going to periodically check back. I've got another tab going here. If I ls, you're going to see we've got some files here. We've got linnugget.error. That's our general error log. And we also have a new file, mysqld-bin.0000001. That's my binary log. And once we start issuing queries against the server, we'll see our general query log file grow. And like I said, we'll periodically check back. But in this example, as we start working with query analysis, we're going to use the world sample database. And to get started, we're going to build a couple tables. And these tables will actually be based on some pre-existing data. Now, if we show tables from world, you happen to know, I'm sure you've worked with this sample database a lot. We've got the city and the country tables. If we describe the country table, this will give us a list of all of the columns in here. What we're going to do is we're just going to grab the code and the name columns from country. And what that looks like, we'll select code and name from country. I'll limit 5. This is just going to give us a 3-character country code, and that's actually, as you see here, the primary key column and the unique identifier for all rows in the country table. And then we have the name of the country. And in the city, if we describe the city table, it's a much smaller table schema-wise, we're going to grab 3 columns. We're going to grab name, country code, and population. So if we select name, country code, and population from city, you see we have a matching column, don't we, right off the bat, country code. So I think you see where we're going here. We're going to actually create a third table. We're going to create one table called countries that's going to pull these two columns from the world.country table. Next, we're going to create a table called cities, plural, that's going to pull just 3 columns from the city table to simplify things. And then we're going to create a third table, or actually not a third table, we're going to run select that pulls columns from both of those tables using this code and country code, which, as you know, is a matching column, as a join. So we'll relate the two tables on a matching column. And that is going to be the basis of our explain-based query optimization. And you may or may not know this. If you don't know it, here's some new information. When you establish a primary key constraint on a table, in particular on a table field, MySQL will automatically create an index based on that column. Now, when we create our tables, initially there's not going to be any indexes going on. However, I get a little ahead of myself. Let's go ahead and build out our tables now. Alright, you see what I've done here. I've done the create table, and I don't know if you're aware of this, but a really nice way to create a table by just pulling data in a select, you can just run the select after the create table statement. Therefore, I've said create table cities, select code name from country, create table countries, select name, country code, population from city. And what's happened is the column declaration data, in this case from country, is pulled from the source table. I can prove that by running a show create table cities, and you can see code is a char 3, name is a char 52. Similarly, if I do a show create table city, country code is a char 3. Nuts. Yeah, they're definitely the same, but you know what I've done? I've loused up the name of the tables. Create table cities, and then I'm selecting from country, vis-a-vis create table countries from city. Well, this is an educational moment, actually, because what we can do is use a really nifty command called rename table. So I can say rename table cities to countries to, rename cities to countries to, and then I'll say rename table countries to cities to. Now if I show tables, I have my original 3, and now I have cities to and countries to. And if I really want to get jiggy with it, I can rename table cities to cities, and we're back in business. Not too bad, not too bad. All right, let's get going here. Our query under consideration is as follows. Let's take a look at a select that grabs 3 columns: countries.name, cities.name, cities.population. Now, you probably know that when you're pulling columns from multiple tables, qualified names are de rigueur. In other words, especially in the case where a confusion or collision is going to take place, because we have the same column name referenced in 2 different tables, countries and cities, we absolutely need to prepend the name of the table to the column name. Now, in a traditional inner join like we have here, we don't have to worry about putting countries or cities first. It would be equivalent here to say select from cities, countries. But regardless, it's crucial in our where statement we set our key values. In other words, where the join is actually transpiring. We absolutely need to make sure this is correct, and it is. As I've shown you earlier, the matching key column in this case is the countries.code field and the cities.country code field. And the where is actually compound in this case. We have the join field, and in this case, the select is also embracing cities.population. We want to filter this query result to bring back only those countries and cities that have a population of greater than 5 million. And you'll note here that we're actually running this query, and it's brought back only 24 rows. And it was pretty fast, come to think of it. Now, if I use my buffer, bring back with the up arrow key, and then I can left arrow all the way to the beginning of this text, we can throw in the word explain, and then hit enter, and we see a bunch of junk. However, we can do \G and get a much better result. Now we're going to get a row for each entry that the table query optimizer has for us. The MySQL query optimizer has for us here. Now check this out. This is not a good result here. Remember I said the first thing we're going to do here is look at what's going on here. We have an entry, one row for countries table, and another row for the cities table. That makes sense because this query references two tables. It's a simple select. Look at the type, all. So we immediately know that we're not dealing with any indexes. And because we're not dealing with any indexes, we have nulls for our key columns. Our reference is null because there's no columns. The rows tells us that we're doing a full table scan because, I don't know if you knew this, but there's 239 rows totally in our countries table, and there's 4,079 rows in total in our cities table. So we're not getting any efficiency here at all. And so that's really it. We've got all for our type, full rows coming back. And remember that when we deal with a join, we have to think of all possible combinations of the two tables. So we're taking 4079, multiplying it by 239, and you're seeing a wildly high number of possible scans. How can we improve this? How can we improve performance is the question. Well, one thing I know for sure is that in our countries table, we know that each code row in this table is unique. And definitely rule 1 in any index scenario is uniqueness. In fact, we could either just develop an index or we can just cut to the chase as an option and go ahead and add a primary key constraint on the countries table. And that's actually what we'll do now. So why don't we run an alter table on countries, and we'll say add primary key to the code column. Simple as that. And remember, in so doing, we now have an index on this column, and hopefully that should improve some lookups on that particular table. Now, as far as the other table is concerned, cities, that's a problem. You immediately see here we don't have enough uniqueness really on any of our columns to do a primary key, but of the three of these, probably the best candidate for indexing is still going to be, at least initially, country code. So we can add an index by doing alter table. Cities will add index country code. Simple as that. So if we use our up arrow a few times, bring back our explain select, let's see what happens. Well, I can see some major changes right off the bat. Now you notice we have all for our cities table with 4,079 rows, so it looks like that MySQL Query Optimizer still performed a table scan on the cities table. Remember that cities is the table that contains the population column, and the whole purpose of our query was to bring back the country name, the city name, and the population number, where the city population is at least 5 million. So in order to parse through all of those population values, it makes sense that MySQL had to go row by row through the entire countries table, or the cities table, excuse me. But check this out. In the countries table, we have an ecref, which means that the join was actually being used and taken advantage of. Possible keys, we have primary, which we know is the primary key index that was used, and only one row was involved. And so, heck, you can't beat that, can you? And remember, the point here is the possible combinations between the two in terms of 4,079 times 1. So, I mean, you went from a huge, ginormous number of possible rows that needed to be scanned in terms of comparing the two join tables down to a maximum possible scan of 4,079. So there's really just one final step. We know that in this case, we're still getting table scans on here, and we know that in this particular query, we're filtering on population. Wouldn't it make sense for us to put an index on the population column? Well, I think it does. So let's do an alter table cities, and we'll add another index on the population column. Let's finish this off by running the explain select again, and now we're down to 25 rows. Looks like we're making use of our queries on both cases. 25 rows examined on the first table, 1 row examined on the second table. We've, in this example, dramatically, and I mean orders of magnitude, dramatically sped up this query. I hope that this has been informative for you in terms of helping you understand the basic elements of query optimization in MySQL. Optimizing Queries Part 1 of 2 Review. In this nugget, we first looked at the basics of query analysis. What is a query, and what are the basic tools or sources for finding slow-running or long-running queries on a MySQL server? After we did that, I showed you the first of a few tools in our tool set for generating hard data at putting some numbers behind our supposition on those long-running queries, and how we can use the explain keyword to then do more creative and intelligent indexing to improve the efficiency of our queries and ultimately our line of business applications that rely upon MySQL Server. I hope that this has been informative for you, and I'd like to thank you for viewing.